Okay, on problem number 11 now. What is it? It's x plus 2 squared minus 4. And the bottom is x plus 2 cubed minus 8. I want to do this a variety of different ways, by the way. And someone says, what are the ways of doing it? One is you could just expand it, and there's nothing wrong with that. But after you expand it, you got to factor it. So what I'm going to start off with is maybe just a factorization of the problem. And what I'm noticing at the top is a difference of perfect squares. So it's really a squared minus b squared. And what does that equal? A minus b times a plus b. All right? So let's write this down. So it's going to be x plus 2 minus 2, x plus 2 plus 2. I will simplify that later. On the bottom, it looks like a difference of perfect cubes. And what's that going to be? A minus b, and then a squared plus ab plus b squared. Let's write that down. So it's going to be x plus 2 minus 2. And what goes over here? X plus 2 squared plus 2 times x plus 2, and then plus 4. Well, let's simplify. On top, what do you see? I see x plus 2 minus 2 is just x. And then I see x plus 4. Relatively simple there on top, right? Let's look at the bottom. What do you see? X plus 2 minus 2, which is going to be x. Now, here comes the tough part. And the tough part is, expanding something. And I'll do this expansion over here. And what do you get? You get x squared plus, well, let's see, 2x and 2x is 4x. I'm just doing this first. Plus 4. Let's do this next, which is going to be plus 2x plus 4, and then plus 4 again. All right, I'm seeing some cancellation, but I'm going to hold off on that until I get the domain of it. I see x on bottom as a factor. What do I see? I see x squared. I see that there. 4 and 2 is 6x. And 4, 4, and 4 is 12. All right, I want to continue to factor it. I'm seeing x plus 4. On bottom, what I see? I see x. I see the quadratic, and it looks like a nice, easy quadratic to do. And what's that going to be? Let's see. I got 12. They get 12, 4, and 4, 8. Yeah, 12. And 4, 6x. Let's see. Not much I can do about that, is there? I made another mistake somewhere. No, I can't factor it. There's no mistake there. I thought it was factorable. I just looked at it. I can't factor the bottom. So let's write that down. And what do I get? I get x and x squared plus 6x plus 12. No, I can't factor that bottom. But what I can do is write the domain down now. What's the domain going to be? It's going to be all real numbers, not equal, I'm sorry, got a little excited there. All real numbers, and I'm going to say x can't be 0. Now, just to play it safe, I also want to, look at the x squared plus 6x plus 12 and wonder, does it ever equal to 0? Well, I would look at the discriminant first, see if it's complex. And what do you get there? It's going to be b squared, which is 36, minus 4, times a, which is 1, times c, which is 12. It's definitely complex, all right? Now, what do you mean by that? There's no real root to that. So it's all real numbers. X can't be 0. The zeros for the bottom there's going to be 2 complex zeros, but I'm not worried about that. So let me erase this over here, and I think I'm ready to write the reduction down now. What's the reduction going to be? Let's see. The x cancels off, and you're left off with x plus 4. By the way, it cancels off conditionally. The condition is x is not equal to 0. And we're done. Thank you.